where echo socket is not closed. Now, in this particular case, if I open up the documentation, this resource leak is actually a little bit different than C and C++. The Java JVM can handle most cases of heap memory, but oftentimes it cannot necessarily manage socket streams and channels in the most timely fashion. So usually the JVM will clean this up, but oftentimes you can have a denial of service if you do not close these resources after they've gone away. So that's resource leak. Guarded by violation is a new checker that we've introduced in Prevent 3.8. This is a race condition checker that's based on our statistical engine. And I'm going to spend about 5 more minutes going through the demo, and then I'm going to take questions. But in this particular case, we are synchronizing lock, and it's protecting this count. As you can see, count is protected 3 or 4 times. And then on line 24, we have an unguarded access with count. So this is certainly a bug. It is major, and the action should be to fix it. Going to update that, and as you can see, the comment history gets appended to our bug dashboard. Now we also have customers that sometimes gray out the bug dashboard because they want all this information to be tracked in their own bug tracking system. Let's go through 2 more bugs: return local and invalid iterator. This is just a very, very simple example, but we have a struct that has an int inside of it, or excuse me, we have a struct that has a member field int, and this struct is on the stack. A is copy constructed onto the stack, and then we're returning the address of that struct. This is commonly known as returning a local variable, returning a stack variable. This will result in memory corruption, and bad things will ensue. The last defect that I want to go over is invalidate iterator. We also support C++. Again, it's a very trivial example, but I've seen multiple cases of these in customer code bases. I is being assigned the past the end iterator, and as you can see on line 6, we dereference the past the end iterator. This, again, is dependent on the FPL implementation, but in most cases this will either crash or X will be assigned a value that is garbage. So thanks for your time. I've got a couple of questions here that I want to go over. One of the first questions is, I use a lot of open source libraries. Can Coverity handle that? The answer is absolutely, and we can actually handle 2 different cases for that. If you're compiling open source libraries, we will actually build that software DNA map as part of the build. So we will actually be able to analyze that software DNA map in addition to your application code. The other case is when you have an open source library, but you are compiling it, but you don't necessarily want Coverity to analyze it. Coverity actually has modeling primitives built into our analysis engine, and we expose those to the developers. I'm just going to jump to our documentation here. Let's look for, here's a good one, Coverity free. Oftentimes writing models will reduce false positives. So if you have an assembly function, or if you have a function where you don't have the source code, you can actually model the behavior of that function through our modeling primitives, and that will let the analysis engine know about the implementation of my free or my open source library. The second question we have here is, I have a custom threading library. Is that okay? Absolutely. In that case, you would still want to model it. So we have modeling primitives for locks. and we're actually able to analyze both C and C++ locks as well as Java locks. Third question, I have different target platforms. Can Coverity work with that? Which ones do you support? We get this question a lot. We support all the major platforms, Linux, Windows, Solaris. I guess you're mentioning different target platforms. In this case, we actually are more dependent on your build environment, not your target platform. So as long as you can build on Linux, Windows, Solaris, HPUX, NetBSD, FreeBSD, and even Macs, we're able to analyze the code. The list of environments that we support is actually quite large, and I don't want to get into this. I don't want to get into the details during this presentation, but if you email info@coverity.com, we can get into more detail with that. The fourth question is, can I write my own checkers? Absolutely. We have a product called Extend, and we expose our AST to you via a C++ SDK. Again, info@coverity.com is the best way to get detailed information about that. But we have many customers that have written their own